Bennu asteroid could impact Earth between the year 2175-2199, and OSIRIS-REx spacecraft is soon to collect a sample of this asteroid. This is one of the NASA asteroid missions, and as you can understand, they're in a very big hurry to find out what this asteroid is made of. That's why they have to collect a sample in order to bring it back to Earth to understand, to ascertain what material this asteroid is made from. Once they know what material it's made from, they can make a decision as to how to move it or blow it up or cut it into pieces and do something to change its trajectory because it's coming towards Earth. Somehow move it out so that Earth is not in risk of being impacted. This is one of the missions having to do with planetary defense. And hopefully it's not just NASA that will be working on this. When they bring back a sample, they will also give it to other agencies so that they can study the sample and perhaps find out what they can do to help get rid of it. Get rid of it. I don't know how they're going to do it. Look how huge this thing is. It's not just taller than the Empire State Building. It's a huge volume. Bennu, designated 101955, Bennu is a carbonaceous asteroid of the Apollo group, discovered by the Linear Project September 11, 1999. So it was just discovered a little while ago. It's a potentially hazardous object. It's listed on the Sentry risk table with the second highest cumulative rating of the Palermo Technical Impact Hazard Scale. It's a cumulative 1 in 2,700 chance of impacting Earth between the year 2175 and 2199, and it's the planned target of OSIRIS-REx mission, which is intended to return samples to Earth in 2023 for further study. Bennu has a mean diameter of approximately 492 meters. That's 1,614 feet. It's been observed extensively by the Arecibo Observatory, Planetary Radar, and Goldstone Deep Space Network. And I'll leave a link below for you for this on a wiki so that you can see the embedded videos of this. They have photometry and spectrometry and the origin and the evolution of these. Bennu originally came from a dying star. Dying stars such as red giants and supernovas. And according to the accretion theory, this material came together 4.5 billion years ago during the formation of the solar system. Asteroid Bennu's basic mineralogy and chemical nature would have been established during the first 10 million years of the solar system's formation, where the carbonaceous material underwent some geological heating and chemical transformation into more complex material. Bennu probably began in the inner asteroid belt as a fragment from a larger body, with a diameter of 100 kilometers, which is of course huge. Simultaneous simulations suggest 70% chance it came from the Polana family and a 30% chance derived from the Eulalia family, whatever they are. Subsequently, the orbit drifted, and as a result of the Yarkovsky effect, the mean motion resonances with the giant planets such as Jupiter and Saturn, various interactions with the planets in combination with the Yarkovsky effect modified the asteroid, possibly changing its spins, shapes, and even surface features. So the thing is though this, all right, let's say you're on a beach. The beach is near the water, and the beach has some very fine-grained sand, right? And you run your feet through it and it feels so good. And a couple of yards away, you have, let's say you're near some Hawaiian island. Let's say you're on a Hawaiian island and you have the nice, fine, sandy beaches. But you also have a little few yards away, basalt, lava, tough rocks. Now, what happens when a sample of Bennu comes back with a fine, what I'm trying to say is, okay, they're going to have a very fast sample take, very fast, going to be on there for a few seconds, taking a fast sample of Bennu, and it brings back to Earth. And people here are going to say, oh, okay, now we have a sample of Bennu. What are we going to do to get it out of the trajectory towards Earth and save Earth and the planet Earth, save the planet? What happens if the sample is not the material that Bennu is made of? You're taking just a little thing like a needle in a haystack. What happens, for example, if the core of Bennu is granite or diamond and the surface is dusty or ash surface, or even icy or gaseous? You see what I'm getting at? I mean, the sample they bring back may not be anything having to do with the actual mass of Bennu, what it's made of. Anyway, that's just my thought. I'm not a scientist, but that's frightening. They have to do something to get it out of the way. That is a given. And this is what the scientists are now telling us. This is the article brief. OSIRIS-REx spacecraft of NASA will soon touch down on the giant asteroid Bennu. It's in the final stretch of deep space. NASA's OSIRIS-REx spacecraft is soon to touch down on this giant asteroid, Bennu, after traveling hundreds of millions of miles from Earth, is what NASA confirms. Sebastian Ketley of Express UK briefs us on this. August 17th, the NASA spacecraft entered its approach phase of this mission. It's an asteroid mission. Of course, they expect that soon enough we will have either an impact or a very close flyby, which could cause an extinction level event. Tweeting from the official NASA OSIRIS-REx account, at OSIRIS-REx, the space agency said the probe will soon begin its asteroid operations. They said, today, after a nearly 2-year journey, I begin asteroid operations and my final approach towards Bennu. NASA probe is scheduled to rendezvous with asteroid Bennu's orbit December 3rd this year. Right now, the OSIRIS-REx is still about 1.2 million miles from this asteroid, which is barreling towards us, but the Deep Space Probe has already begun imaging this asteroid, and it's beaming back information to NASA, to scientists back on Earth. The Origin Spectral Interpretation Resource Identification Security Regolith Explorer, or OSIRIS-REx for short, is the U.S. Space Agency's first deep space mission, which has the goal of retrieving an asteroid sample back to Earth. This space probe blasted off September 8th, 2016, and operations will continue until March 21st, 2021. This spacecraft will return to Earth with a piece of this gigantic asteroid on board. NASA said the spacecraft's official arrival at Bennu is scheduled for December 3rd, 2018. That's when OSIRIS-REx transitions from flying towards Bennu to operating around Bennu. They said, quote, while the asteroid OSIRIS-REx will survey and map Bennu, navigate in close proximity to the asteroid, and ultimately touch the surface for 5 seconds to gather a sample of the asteroid, end quote. 3 nitrogen gas canisters on board the spacecraft will ensure OSIRIS-REx can attempt up to 3 sampling attempts to collect enough asteroid material. To ensure everything goes according to plan, in December, NASA is planning a minimum of 2 rehearsals before the 5-second approach to collect the samples. NASA spacecraft will practice leaving its orbit to dip about 410 feet above the surface of Bennu, and the attempts will give NASA and OSIRIS-REx opportunity to verify the space probe is on course to collect asteroid samples. The spokesman for NASA, Lori Loney Shechtman, said samples of Bennu will return to Earth on September 24th, 2023. A quarter of the collected space rock will remain at NASA's labs, and the rest will be donated to scientific institutions, to other ones around the world. And you can see here what they estimate to be their the OSIRIS-REx size compared to asteroid Bennu. It's like a little, well, what is it? I don't know. It's just tiny. Now, comparing this to the Empire State Building or Eiffel Tower, the asteroid Bennu is the height of 510 meters, for example. Empire State Building is 443 meters, or let's say yards, height. And the Eiffel Tower is a lot lower. It's at 324 meters or yards height. So it's quite huge. It's not just the height, it's also the volume of this thing. So we can watch OSIRIS-REx mission briefing live online this week. And the audio of the teleconference will stream live online on NASA Live. The briefing of features appears from Acting Director, Planetary Science Division, Lori Glaze, and the OSIRIS-REx Flight Dynamic System Manager, Michael Moreau, and Sandy Freud, OSIRIS-REx Mission Support Area Managers. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.